curriculum night, but it is posted on there now. I got it there this morning. And these will be posted right at the end of the day. So again, like I was saying, when we did that simulator, the coin simulator, we flipped the coin multiple times. The more often we flipped it, the closer that probability got to the theoretical probability. So that's what's really important. You want to make sure that you understand the larger the trials, the more accurate the data is going to be. So let's write that down. To get the experimental probability, to be as close as possible, and when I say close as possible, I mean almost equal, right? They're never going to be exactly equal, but it's going to be almost equal to where when you estimate it, it comes out equal to the theoretical probability. You must perform your experiment a large number of trials. Or perform the activity. So like I said, the more trials, the more accurate. It's really important that you make sure you keep that in mind. You want to perform at the largest number of trials that they offer. Okay, and then before I let you get into your assignment, let me go over one more thing, which is the probability prediction proportion. Who knows what I mean when I say a proportion? Diego?
It's like a fraction equals another fraction, but the other fraction equals a percent.
Okay, well, it might be a percent. That's a percent proportion. Okay, so that's where you've got a fraction that's equivalent to another fraction that involves out of a percent. We call that like the part over a whole equals percent over 100. In probability, it's the same idea. You have a probability, which is a fraction, and you're setting it equal to something that you're trying to predict. So probabilities can be used to make predictions. So if I know that the probability of a student performing well on the next assessment is, 75%, well then, if I want to figure out roughly how many kids in my class are going to do well, I'm going to take that probability of 75%, which is 75 over 100, and set it equal to X out of however many students I have. So in this case, 34 students in this class. Then I would do a cross product to solve and see roughly how many kids would I expect to do well. That's called our probability prediction ratio, or proportion. We are going to be using that for this unit and for our statistics unit, so you want to make sure you become comfortable with it. So let's take a look at a problem. Let's say yesterday we had, 60 customers. Bought muffins. And 12 were blueberry. So if I know that I can expect 100 customers, so I expect 100 customers on Friday how many blueberry muffins should I make or prepare? So 60 customers came in yesterday and they bought 12 blueberry muffins. So if I know I'm going to be expecting about 100 customers on Friday, how many blueberry muffins should I prepare in advance? So again, what you're doing is you're setting up a proportion and you're taking the probability that the event is going to occur. So the probability that we're looking at is blueberry. So I want the probability that blueberry is going to happen. So the probability of blueberry is 12 out of 60, isn't it? Because that's what happened. We had 12 that occurred out of 60. And then I'm going to set that equal to what I want to predict. So making a future prediction of blueberry. So I need to know how many blueberry muffins am I going to make, X, if I can expect 100 customers. And then we're going to go ahead and do our cross product to solve it. So the cross product indicates that we would multiply 60 times X to get 60X, multiply 12 times 100 to get 1200, and then from there solve that one-step equation by doing inverse operations and balancing the equation out. So what inverse operation am I going to perform here? Okay. Valina. Division. Okay, so we're going to go ahead and divide both sides by 60. And how many blueberry muffins should I go ahead and prepare then? We do 1,200 divided by 60. What would we get? 20. Good. So I could expect to make about 20 muffins.
French-Zheng,
Yes, ma'am.
please pardon the interruption. Do you have
I'm sorry, you cut out.
Ava Hines with you?
I do not.
Okay, pardon the interruption. Thank you.
Okay. Okay, number 2. I want you guys to go ahead and try this one on your own. All right, a bag of fun-size Skittles has 2 purple, 3 orange, 6 yellow, 1 red, and 1 green. If a king bag has 150 Skittles, how many purple would I expect? You finished? Okay, just hold on 1 second, okay? I think I'm just going to call on a random student. So I have a little generator up here that will pick a desk number 1 through 34. So if it calls on your desk, go ahead and let me know what you got. So again, bag of fun size Skittles has 2 purple, 3 orange, 6 yellow, 1 red, and 1 green. I have a king size bag that has 150 Skittles. I want to know how many purple should I expect in that bag. So let's go ahead and call on desk 21. 23, very good. And it's actually not exactly 23, right? You'd have to estimate it or round it. So if we're looking at the probability for purple, there's 2 purple that occurred out of a total of 13 Skittles in the bag. And then we're going to set that equal to what we're trying to make a prediction for, which is X out of 150. And then we just do our cross product. So we're going to multiply 13 times X, and we'll get 13X. Multiply 2 times 150, and we're going to get 300. Then when we divide both sides by 13, we're going to get, I think it's like 23.07. Yeah, it just keeps going, right? So it's going to be approximately 23 Skittles. Okay, now your assignment, I've already written it on the board. It is out of the workbook, so I went ahead and printed it instead of you guys having to have the workbooks. Like I said, I made copies for it. But if you happen to lose it tonight, you know you can always go onto your e-class, and it would be on pages 205 through 208. And you're only working on problems 1 through 6. Problem 8, and then problem 10 through 18. So you're not doing number 7, you're not doing number 9. You're not doing number 7, and you're not doing number 9. You can cross those off. If you want to do them, that's fine, but we're not checking it, okay? We're only checking the problems that I've assigned. Once again, make sure you answer all parts to the problem. I'm going to go ahead and stop the video.